Good afternoon, all, and hope you all enjoyed your lunch break and had some good opportunity to network with your colleagues and new, network and friends and other members from local government, industry, and agencies. So, thank you all for being here after lunch. I'm sure we have a broad suite of presenters with a wide range of topic addressing some really key aspects of landfill management and how to improve the operations and also mitigate some risks. So I'm sure they will all keep you enticed and engaged through these presentations, especially after lunch. So thank you all, and thank you to all the presenters here. We have Chris from GHD, Dr. Jessica North from LGI Limited. We have Kate Beard from SMEC, Australia Private Limited, and Ronan Cullen from Talis Consultants. Coming with a broad range. Yes, we have these presenters who will be presenting for 20 minutes. There will be opportunity for questions, Q&A at the end of the sessions if time permits, but there's also an opportunity to post your questions through the app, the conference app, if you do. And obviously there's also the afternoon tea where you can network and probably have a bit more conversation on different with the different presenters. May I, before we start on with the presentations, and I call upon the first presenter, may I request everyone to switch off their phones or put them on silent, and that'll be much appreciated. So our first presenter for this afternoon is Chris Nivison-Smith. Now he's with GHD with over 15 years of experience, predominantly in landfill design and construction and and infrastructure development. Been in this field for quite some time with vast experience. He's bringing some great insight into what the future of the landfills should look like or might look like. So his topic for today is Tomorrow's Tip Today, Reimagining the Landfill of the Future. So he's going to take us through the future of landfills. So please welcome Chris.
Thanks for that intro, Kartik. I'll get going straight away. Starting off with a quote. I've always wanted to start a presentation with a quote, so there you go. The people that are here, we've talked about it a lot already in the conference. There's constant change happening in our industry, and the landfills are also seeing a bit of that. We're seeing what's going to happen to the landfill, which is still going to be an important part of our waste hierarchy, but obviously its role is evolving and changing, and the requirements of a landfill is changing, and what is that going to look like in the future? So, why are things changing? What are the drivers around that? I've listed a couple there. I'll point to a couple there. The residual waste streams, that's something we've been talking about a bit this conference. We know aspirationally at least, or we know it's coming, we're going to see more concentrated residual waste streams being sent to our landfills as we're diverting, have diversion activities like FOGO. We get more energy from waste plants, and generally we're driving towards circularity anyway. We're going to see that more concentrated flow, and that's going to change how we design and operate these landfills. Unless you're in the US, generally environmental regulations are getting more and more stringent as the years go on, and that's going to require more and more out of us on how we operate our landfills. Again, another topic we've been talking about a lot in this conference is that increased community awareness and a very active community in our space, and they care, and there's a lot more stringent social license to operate and get things right. And a couple of those other topics I'll touch as we go along. So I was going to put up a QR code here, get you guys to scan it, tell me what you think the future of landfill is going to look like. That would have shot me to pieces in terms of timeline. So I just asked some of my fellow landfill enthusiasts in the industry to ask them, what do they think? And you guys can have a bit of a read up there. I do like the robo landfills one. That one's my favorite. Yeah, look, it's nothing new, nothing surprising. A lot of topics we've been hearing about. Where's the leadership? How do we get new projects approved in future? PFAS, what are we doing about that? So a lot of these topics I'll try and cover as we go along. And yeah, one more slide on ground rules. Yeah, I only have 20 minutes here, so I do have to put some gates around what I'm going to tell you. When I say future, I mean near future, so say like 30-year horizon. I'm not going to tell you what's happening in 100 years' time because, I don't know, we might not have waste or we're sending it in rockets to the sun. I don't know. I can't give you that answer, unfortunately. I'm focusing on the landfill itself. Obviously, we have these integrated facilities. We divert waste, we collect waste, we recycle it at these landfills, but I'm really looking at the landfill itself. Focusing more on operational sites, obviously there is a lot of sites that need to be closed and rehabilitated in the near future, and I guess if the economics work out, maybe we'll be mining them as well. That's a topic for another day. And I think I'm repeating myself here. I won't cover everything. I'll try and cover as much of the key issues as I can, but I'm happy to talk about it later. So it would be remiss of me not to talk about the modern landfill before I talked about the future landfill. And look, you'll have to humour me. I'm sure most people in this room know what a modern landfill looks like, but I'll quickly go over it anyway. It's a nice picture up there of one. So you have the liner system that goes around the base there. On top of that, you have a leachate drainage system, so typically gravel with pipe work. And then above that, we have the waste itself being placed in horizontal lifts with covering going on, and then eventually we put that final cap on and we seal it. In terms of leachate, we're extracting it from that drainage system and then sending it to some sort of storage solution. Say, the picture there has tanks, but typically we use ponds out here. And then we're thinking about disposal. Are we treating it first and then sending it to sewer? Are we looking at things like irrigation? There's a number of different methods we use in Australia. From a gas point of view, if it's viable, we're extracting gas out of the system, and then typically in Australia, we're looking at, well, can we use, can we generate energy with landfill gas engines, or if that's not viable, at least we're sending it to, say, a landfill gas flare to reduce that greenhouse gas emissions footprint. Oh yes, so we've got, the other one we've got there is the monitoring devices there. So we have some groundwater monitoring, we have some landfill gas monitoring, we do surface water monitoring as well. So all these sorts of things that we do just to make sure that our sites are complying with their licenses and that we're able to pick up issues if they arise. So I'll start with containment. And a lot of this draws me back to, I've done a lot of designs of industrial facilities and hazardous waste facilities. And I think when we look at these concentrated residual waste streams, that is generally where we're trending. So when I look at the design side of things, for a general waste landfill at the moment, it varies slightly across Australia, but generally you're looking at a clay liner and alongside a geomembrane working in composite. If you don't have clay, you can look at an alternative like geosynthetic clay liners. But it's a pretty stock standard design. And when you're looking at these facilities, it's likely we can't just roll that out. We're going to have to think about more site-specific testing. Is it testing of the leachate quality, the waste characterization stuff? And then playing that in with how we test our materials that we're using for our liner systems. So a bit more thought and refinement around how we look at that. From a component standpoint, we have these composite liners in industrial facilities. That's not enough. We have to look at what's called a double liner system. So we're effectively taking that liner and doubling it up again. And that may be required, particularly when we think about the PFAS problem we have. There's a lot of research obviously happening with PFAS at the moment. One of the big ones that's come through, there's a professor by the name of Kerry Rowe, very famous in our field. He's actually an Australian. He's a good guy. He's picked up that, PFAS has a real impact on the service life of, say, geomembranes and things like that. So that sort of thing we have to think about and say, well, we can't keep doing the same thing we're doing if we know there's now a known issue in that. That being said, there's a lot of innovation happening in the field. We're seeing people come up with new products as they do when we have new problems, things that are better equipped to protect us against, say, PFAS migration and things like that. So a lot of interesting happening in the field, but it's likely to change the way we look at these lining systems. Robustness and, again, with these industrial facilities, we have what's called a leak detection layer. So between those two liner systems, you put a drainage layer there, and that way you're able to pick up leaks. If you were to have a breakthrough through your primary liner, you can pick up these leaks and be able to, as well as pick them up, you can also use that as a drainage system to be able to manage that and not let it just go straight into the environment. So those sorts of redundancy and contingency measures, that's just one. We're likely to look at more and more contingency measures because we want to make sure that we can stop things. If things invariably do go wrong, we have measures to try and limit the effects of that. And monitoring, it's relatively widespread now. If you build a landfill cell recently, we have leak location surveys that we do on our liners, and that's great stuff. It's really about validating the liner that's been installed is in line with, it's best as it can be. There are some more advancements happening, so we're putting conductive materials inside geomembranes and geotextiles just to make that liner survey as good as it can be. And again, it's all about installing a product that we're happy with, and it's at its best level that it can be before we start putting waste in there. Landfill gas. So I'll be careful here because I've got Dr. North in the room, but I'll try and stay in my lane a bit. Landfill gas is a great field for incremental improvements. We've been seeing that year on year. I remember when I started in waste 15 years ago, we have landfill sites that they'd look at and say, well, it's not really viable for us to get gas out of this site. But now we can come back to these sites and say, actually, with our increased, our optimization of our extraction measures and things like that, we can now get gas out of those facilities. Things like that. We're seeing battery storage going alongside our landfill gas engines. We're seeing all sorts of improvements there. And in general, it's got a great environmental outcome in that the more gas we get out, the less fugitive emissions we're seeing get out of our system. So it's all good news there. Refinement, and look, I'm a little bit biased on this one because our company does a lot of work in this space. There's a real opportunity, we think, around converting that landfill gas into renewable natural gas. And I say that because you look over in North America and Europe, there's a lot of activity in this space. You're seeing, I think, about 110 renewable natural gas conversion facilities, either in planning or that have been built in America, and there's plenty more to come. And the reasons they're doing this, there's opportunities to reduce the emissions. You're refining that to a biomethane, essentially. And there's a lot of revenue potential putting that back in. Granted, look, that is being driven a bit by market incentives. Things like, I put some examples there around North America having low carbon fuel standards, tax credits for renewable fuels and things like that. So there is a bit of requirement of the market creating some incentive and intervention for that happening. But given what we're seeing overseas, it's very likely that that's going to happen over here as well. So that's the good stuff. I think the hardest stuff we have to think about is if we do have these more concentrated waste streams, these more residual waste streams, we're going to see a change in the amount of gas that we're going to get and also that quality of that gas. And I probably used the wrong word there, viability. I think it's more feasibility. It's just understanding, yes, we can still do these things, but we're getting less gas. We're maybe having to do more treatment because we have more hydrogen sulfide or other things like that. The cost is adding up. The revenue we're generating is getting smaller. Does that change the balance of how we look at our feasibility of these facilities? So definitely a bit of a change there. And then, PFAS, everyone loves PFAS. They've done some research recently and they found PFAS in landfill gas emissions as well. Good on you, it's just getting everywhere. Another problem, another thing that may impact our feasibility. We're going to have to come up, and I'm sure we will come up with a solution if we don't want to have one already. And the regulator is going to turn their eye to it at some point. Again, it's just another challenge to overcome. Maybe it impacts on our feasibility of how we look at these things moving forward. I've lumped in leachate and surface water into one thing, just to make it a bit simpler here. So climate change, if you're not aware, recently the Australian Rainfall and Runoff Guidelines were released an update which has climate change projections in there. It tells you how to apply that to your projects if you're, say, sizing surface water infrastructure and things like that. It's a bit of a dog's breakfast at the moment. Everyone's still trying to work out what it's actually telling us to do and how to do it. But look, we know what it means. We know we're going to see higher and more sustained peak events. We've seen it in the last couple of years with all these La Nina. It's really going to put a strain on our systems. In particular, we're going to see more leachate, obviously. We're going to have to think about increasing the size of our surface water infrastructure. And, if we're starting to look at new sites, do we have, siting constraints that we didn't have before around floodplains and sea level rising? So it's really about, thinking more into the future. You're not sizing things just for today. You're thinking about how long your facility is going to last and future-proofing it around that. So just a bit more nuance and thought around that. Again, PFAS. I guess this is maybe other people might think differently. I think it's at a bit of a standstill at the moment that everyone's cognizant we have an issue. We have PFAS in leachate. The regulator wants us to get it out. The Water Authority is saying, well, maybe it makes more sense for the landfills to be doing it. The landfills disagree. And so there's a bit of a standstill around who's going to actually deal with this problem. Putting that aside, say if PFAS removal had to happen at our landfills, we had to roll out treatment of that, it starts making you think a bit around our disposal mechanisms and saying, we're going to apply such advanced treatment to get PFAS out, to get other contaminants out. Do we even need to send it to sewer anymore? Do we have such a high quality water? Can we look at other simpler mechanisms like just irrigating on green fields or releasing to natural waters. It's something we don't really do in Australia. The regulator doesn't like that idea at all, but it is done in America and other parts of Europe as well. And potentially, we go down that path if we're having to spend so much time and money and effort on removing PFAS and other emerging contaminants. And speaking about other emerging contaminants, yeah, look, they'll keep coming. The fun will keep going. Microplastics seems to be the next big one. There's been a lot of research done that's shown that surprise, surprise, there's a lot of microplastics in our landfill leachate. So the regulator at some point will get onto that, and we'll see what that means for us. But in general, look, I think the leachate thing, I'm sure the landfill owners and operators will agree, it's a societal problem that we have, and a landfill is a repository for society's waste, so of course there's a concentration of leachate, of PFAS, but the issue being that we're essentially, landfill owners and operators are being penalised with this problem and having to deal with it, and also being held for penalised for having to manage it. And it really should be a more nuanced conversation, a more positive dialogue around getting everyone involved and at the table and coming up with a pragmatic solution together. Aspirationally speaking, but hopefully they can do that. Yeah, again, I love the robo landfills ones. I just chuck this in. Look, we already have a lot of great technology at our landfills, anything from drone surveys to the instrumentation and control we have for leachate and landfill gas. We can run these systems basically from a computer, another country away. It's fantastic, and this will keep going. We're seeing a lot of movement from my point of view in the landfill gas monitoring market and using drones to monitor landfill gas. So hopefully that gets rolled out soon, and in the future. We're already seeing it in construction. There are some certain plant and equipment that is remote control. Do we roll that all out? Are literally our landfills run by robots at some point? Maybe, maybe not. But we should really be considering these innovations. And I think the big takeaway for me is innovations and our regulations always have a bit of a balancing act. We don't want to have too strict. We want to have stringent environmental regulations, but we don't have to the point that innovation suffers, because all this stuff has the ability of improving safety and performance and compliance at our landfills if we get it done right. Yeah, I don't think I'll speak too much to this slide, because to be honest, you guys have been beaten over the head with all this stuff over the last couple of days. There's been a lot of great conversations at this conference about new waste infrastructure, how are we planning for it. I echo some of the words there about it's great to have a plan, but who's responsible for this plan? How do we have a pathway for getting to this plan? And is it reflected in our regulatory instruments when we come to go get these facilities approved? So I don't think there's too much more I'd want to add to that. I've talked a little bit there about siting. If we're going to look at new landfills, it's very unlikely to be in metropolitan areas. We're probably going to be putting them further away. How do we get the waste out there? All those sorts of challenges. Getting some leadership from the state, which we're seeing some positive leadership at this conference around that, and hopefully they keep delivering on that. How does the funding work? And social license is probably one of those big ones around. Another topic that was brought up is saying, yes, the state government has a big role in this, but everyone in this room at this conference has a role in this. To me, it's a lot about saying that portraying landfills as we want to in our industry, knowing that if we're talking about them, not necessarily demonising them, saying yes, they have a role in our waste hierarchy. It'll be a reduced role, but still an important piece of infrastructure that we have to have involved in waste management. And also our general facility operations, making sure that we're operating those things as best we can, because we all know there's one issue at one landfill somewhere and there's a big domino effect, and all of a sudden the whole industry is impacted by that sort of stuff. So final thoughts. Yeah, look, I think nothing really groundbreaking is what I'm talking about here today. I think we're not changing completely how we look at landfills or how we manage them. We're not reinventing the wheel. It's more about that incremental change and staying ahead of the game. And I think we have a lot of opportunity to look internationally, say at North America or Europe, where they're a bit further along in their landfill journey, or even just look at general industry trends and be ahead of that. And that there is that opportunity. It's are we taking advantage of that? I just said it, state and national leadership is important, but we all have our part to play, so let's make sure we're all doing what we can, because landfills are going to be here for the near future at the very least. Again, talk about that balance, not only from an innovation standpoint, also pragmatic solutions around leachate. Have we got that balance around the regulations versus where we need to get to, and just refocusing in on what are we trying to achieve? With PFAS, it frustrates me because obviously we have an environmental problem. Let's solve it. Let's reduce this impacts to human health, but it's all getting stuck in a money conversation. So it's trying to get away from that and looking at solutions. Yeah, I think I started on a quote. I'll end with a quote. Failing to plan, planning to fail. I think there's there's already a lot of positive movement happening there, but we need to keep that momentum going. We need to keep planning. And I guess, I look at some of the planning they put up there the other day on infrastructure, and there's a lot of scenarios. Apparently now in Sydney, we don't have a putrescible landfill problem anymore, magic. But they're looking at, you look into those scenarios and it's like, oh, we're going to, this is all going to get solved by 2 energy from waste plants, not only getting approved, but also getting constructed, a landfill expansion getting approved and constructed. It's a lot of ifs there. And I would hope that there are multiple scenarios being modelled in all these plans, and we're catering for all these multiple scenarios, because we don't want to get caught short, particularly in a field like landfills, where if we have to all of a sudden augment that, it's hard yakka to get the community on board with that. So, my final thoughts. Thank you.
Thanks, Chris. That was a very impressive presentation and really good insight into the future of what landfill should or would look like. Considering the time, we'll proceed with the next presenter, but we'll try and kind of reconvene with the presenters should we have some time left in this session for any Q&A. So our next presenter is Dr. Jessica North, who's been in the waste industry for more than 2 decades, in resource recovery, particularly looking at different aspects of landfill management, gas management, and while she's been with LGI since 2012, she's been working on various gas infrastructure projects. She's got a whole gamut of experience in waste and resource recovery and recycling across Canada, US, UK, and Southeast Asia. So, also, she's been the CEO of LGI Limited, which is now an ASX listed company. So, and she's presently the Chief Sustainability Officer with LGI, looking at carbon, and that's her kind of forte and her baby at the moment. So she's going to talk a bit more about carbon. So welcome, Dr. Jessica North. Thank you.
I think there's a phone up here, by the way. Does that? I know everybody was expecting a toddler to be up here. I mean, 2 decades in waste, clearly, but it's all right. No. So I'm going to actually grab a mic because I'm not very good. I get a bit active and I'm not very good at sticking in front of this one. Lovely, thank you. So I'm going to go reasonably rapidly through the slides because I think that there's a basic and a very intermediate understanding of waste and landfills and what happens in landfills, etc. And I've got a little bit of a surprise at the end of my presentation. So first of all, the title of my presentation is an awfully big mouthful. And the key message that I want to get across today is that there is untapped opportunity in the landfill landscape in Australia to achieve greater greenhouse gas reduction and benefit for our communities. So as we all know, we've got probably around 2,000 known or registered landfills in Australia. Most of our waste goes to a handful of those sites in metropolitan areas, but the majority of those landfills are in regional Australia, operated and owned by local governments, and many, many of those sites do not have landfill gas recovery. They don't have active gas extraction systems. And there's good reason, because our local governments, particularly in regional areas, are often under-resourced, right? We struggle to have the resources to not just to procure the system, but to install it, operate it, etc. but also because the regulatory environment in Australia generally doesn't say you've got to do active gas extraction on your landfill. So if you're going to your community and saying, oh, we're going to have a rate increase because we're going to put in this gas extraction system that nobody's telling us we have to have, okay, it's the right thing to do, but it's going to increase your rates by, umpteen amount of dollars, who's going to support that? Eventually, our regulatory environment has to catch up, because if we are putting municipal, putrescible, biodegradable, waste into a landfill, we should be capturing the gas, because the gas is going to be inevitable. 50% CO2, roughly 50% methane, global warming potential, human health and ecological risks, it's got to be done. But we are not there yet. So in the absence of that driver, that regulatory driver, there is an opportunity right now to use the government's, the federal government's ACU scheme, or it used to be called the ERF, Emissions Reduction Fund. It's now called the ACU scheme, and to actually get these projects funded through the generation of carbon credits. And that is the point of this talk. But there's more. I just want to explain that LGI, we are one of the smaller landfill gas recovery specialist companies in Australia, but we're not pro-landfill. So we would love it if tomorrow every landfill in Australia closed because we had the whole diversion, the whole circular economy worked out. And that, as a team of professionals, would be our ideal. But we would have a legacy issue. So, for example, we currently operate on 29 landfills in Australia. 5 of those are closed. And one of those we have been generating energy from. So we have 8 landfill gas to power stations that we own and operate. And one of those power stations has been operating on a site that closed over 20 years ago. And we've been generating power, initially 1 megawatt of power, since 2012. So you close those landfills tomorrow, and whether you're generating power or you're simply dealing with the methane, you have got gas coming out from this legacy issue. So I do not see that landfill gas recovery and projects are in any way counter to all the essential FOGO, recycling, circular economy initiatives that we have to be pursuing. But managing landfill gas is part of the solution, given the global warming potential of methane, which is huge, and it's getting considered, scientifically considered huger, more huge, anyway, that we need to do something about it. And this is a low-hanging fruit. This is a little apple that we can all grab, potentially. Now, so we're going to go through, and you'll notice that LGI, we have several large projects on large metropolitan landfills, but the majority of our sites, as you can see, on the eastern border of Australia, are regional. So we work largely in the regions with smaller sites. So, just briefly, how would a project create carbon credits? So when you are considering, say for your landfill, you want to put in a project, one of the most important things is that project is not going to occur without the incentive of carbon credits. So you need to get a project registered before you actually engage somebody to do the work. Before you make that financial decision to go ahead with it, you need to have a project registered under the government's ACU scheme. And when gas is recovered, when you suck the gas out and you treat it and you run it through a flare and you combust it, because the methane is converted to... Costa, I think Costa is calling. I'm here, Costa, it's okay. No. So when you, because the methane is converted to less harmful carbon dioxide and water when you combust it, right? You have got an abatement of a greenhouse gas and you get carbon credits. So it's a little bit more complex than that. And obviously if there's enough gas, and you can work through the crazy interconnection piece, which is very expensive and a logistical nightmare at the moment, then maybe you can put on a power station, and that would be fantastic. I'm not going to talk to RNG, Chris. You and I can have a chat about that later, but it's an interesting one as well. So now we get to the interesting part. In Australia, since the Carbon Farming Initiative, the CFI Act was introduced in 2012, 2013, there is the concept that every landfill in Australia ought to be doing something, ought to have some level of gas capture. And so the first 30% of anything you do is considered the default baseline. So when you capture all this gas, you would get carbon credits for 70% of everything that you're capturing. Now, this landfill gas methodology has been going under a government review since, if people are aware of the Chubb review, where the government engaged Professor Ian Chubb to review, because there was a concern that there was a lack of integrity in some aspects of the ACCU scheme of the ERF, and landfill gas methodology came under scrutiny. And so, unfortunately, these things take time. So we've been working on this new method for about 14 months. It's a fast process, as you can see. But at the moment, we have a landfill gas methodology, and we are anticipating a new landfill gas methodology. It is complex. The calculations, I won't say loopholes, how do you say, like the curvy bits around this, how you apply it to a site, what gives you credibility, what allows you to be eligible, it is complex. But if anybody has questions about projects or wishes to discuss further, please come and see me. Unfortunately and sadly, I've been living this for about 12 years of my life. So there we go, for my sins. The wonderful thing about landfill gas credits, though, is that once that methane goes through your flow meter into your flare or your engine and it's combusted, it's a permanent destruction of the methane. It doesn't come back. It's not going to reappear. And so it is the most fabulously instantaneous, verifiable, high-integrity credit that you can generate under our current system. So I would encourage all landfills to consider whether or not they should go for this. I'm going to give you some case studies, because something that we have found is that a lot of local governments think that their site is too small, too regional, isn't eligible, would never be eligible to consider getting a landfill gas system. Not every site will be. There are some sites which are simply not commercially viable for a company like ours to come out and assist. However, it is worth investigating because so many are, and we are in conversations with a great number of councils. I'm going to go through 4 examples, and then I'm going to do a very quick little exercise with some of the people in the room. So first of all, with Gympie Regional Council, when we started at Gympie Regional Council, and I'm just going to give you the tonnages that they currently accept. I think it's about 45,000 tons per annum that they receive. Yep, thank you, Christine. So again, understanding, but when we started to work with them in 2016, that tonnage was much less. And it was a very marginal site. The flow rates were very, very low. I've only gone back to 2018, but you can understand that the flow rates were really low. Look at where we're heading to now. With the increase, the continuous investment in gas, and I've given you a sort of a warts and all view. When you put in a landfill gas system, it is not a set and forget. You have to continuously invest in that system. And once again, if you've got some revenue or you have an incentivized landfill gas supplier who's getting carbon credits, there is incentive to continuously invest in that system to continuously capture the gas and chase the gas on the site. Give Gympie another 5 years, you might even be looking at a power station. You might have sufficient gas flow for a power station. But once again, in 2016, tiny regional site that may have been overlooked if we hadn't completely nagged them to death and said, please, please, please consider going out for tender. And once again, none of these landfills have a landfill license requirement to capture gas or do anything with it. The license does not require this. So these councils have gone above and beyond any EPA or license requirement. The second example is Hawkesbury. We've been working with Hawkesbury. We had an original contract, and the contract was a little bit frustrated by some procurement issues, by some constraints we had, and the project lapsed after 7 years. We were able to work with council to get back on site. Through COVID, you can see COVID had an impact on our ability to access the site. Gas volumes dropped. We renegotiated contract, and you can see where the gas volumes are going. So that continuous communication and an alliance type agreement with a contractor, very, very critical to continuing to chase gas and to consider options. There are so many options for regional. I'm going to skip over this one because I'm missing Clarence Valley Council from the audience. Shoalhaven. We took over this project. It was an upgrade project. In other words, the gas system already existed, but it had been somewhat neglected by the original gas supplier. The contract lapsed, and we were able to take the contract on. This site is tagged for a power station, and you can see, this is gas flow. You can see the sort of flows that we have achieved on the site. And I'm going to keep going quickly because I'll get to where we're going, 5 minutes, yeah. And finally, Tari. We have not installed the system yet, but I have included Tari because the Mid-Coast Council started the tender process about 2.5 years ago, 3 years ago now. When considering these projects, the procurement processes are onerous. We are seeing 2 to 3 years to obtain gas systems. We need to act quickly because the appetite for offsets, for carbon credits, et cetera, the policy environment is changing. And I believe that this window of opportunity will be closing or becoming less interesting in future. But I want to now do a little something. I have a representative from each of the councils, except from Clarence, unfortunately, and I have a question because I want you to hear from the people who have installed these systems and from the councils themselves. So my first question is to Christine Blanchard from Gympie Regional Council. Council went out to the market in 2016 with a request for tender and had a contract fully executed within 6 months. How and why did Council act so quickly?
Thanks, Jessica. I actually don't have a 100% answer to that because it was my predecessor who actually did it. But it's my understanding that he actually had a huge desire to have it in and he just basically rammed it through. My experience in another council where we have actually got signed documents before I left, but it's still not installed, was procurement. Procurement don't necessarily understand how to sell something, they only understand how to buy it. And the legislation is not geared up easily for this. I think if the answer is if you want to make it happen, you can, but you can also get tied up in huge knots with your procurement people. But persist. I got it through at Lockyer Valley and they're still not installed, but the paperwork's signed.
Thank you, Christine. The next question is, and that is absolutely something, having people behind the project, having a champion is critical. So a quick one for Hawkesbury. Have we got Samuel? Oh, there he is, sorry. One more. Could I ask, over the 10 years that Council has had LGI operating the landfill gas system on your landfill, what has been a key challenge and a key benefit for Council?
Thank you. I think for us, the fact that we have landfill gas capture is quite critical. We've had multiple notices with EPA around our landfill gas migrating from site. So having a contractor on site that can help us address those key issues. So we've had greater than 1% landfill gas migration. So that's actually helped us reduce that. And particularly having a proactive one that can actually work together to minimise it even further has been great. I'd actually probably go back to procurement's the key issue in New South Wales, anything over the $250,000 either bought or sold has to go out to tender. Procurement have no idea. Waste, even in the waste space, we often don't have any idea about how we can procure this to go out to market and get a great result for us and our community, but then also making sure that it's incentivised for LGI or other contractors to come on site. And I think part of that's probably the key challenge. Yeah.
Thank you. And I'll do one last one, is for Peter Windley. Yes, thank you. From Shoalhaven City Council. What one piece of advice would you give to a council when planning for a possible landfill gas to power project? Or, I had another question for you, but I cannot see it there.
Thanks, Jessica. The one piece of advice I'd give would be, and touching back on Chris's presentation actually, is treat landfill gas as core infrastructure right from the start and get into your planning. Get it in, not a bolt-on afterwards. Well, it can be done. It's better to plan and get it right. We've coming from a very different place where we generated for almost 20 years. Jessica touched on it before. We had contractual issues with the previous contractor and our gas when it was all over the place. LGI back on board, and now we're looking at doubling the generation, batteries and all sorts of good infrastructure. For those out there building landfill cells, install at early stage, install the infrastructure early, vertical wells, do it all, get it as soon as you can. And most important thing is partners. Look for really strong partnerships that can deliver with all those procurement issues that we just talked about. Good, strong partnerships will end up in the right place. And yeah, is that enough?
Thank you. And it's not a promotion of LGI, it's just trying to explain there are opportunities. Please reach out to the councils. And if you have a chance to talk about actually the tendering process to get a landfill gas system, please reach out to David Rees from Mid-Coast, right at the back there. I don't have time to ask you the question now, but please reach out to him about that timescale and challenges with the tendering process. Thank you very much.
Thank you, Jessica. That was great and good insight into what needs to be done and how well councils could be prepared in terms of installing landfill gas and getting that those credits through ACCUs. Our next presentation, it's a good segue from landfill gas to landfill closure, which basically are basically supplementary of each other. With good planning for landfill closure, we can extract and maximize gas extraction. And we have Kate Beard from SMEC Australia. Kate has almost a couple of decades of experience, in landfill in infrastructure development, predominantly landfill sales, designing from planning to procurement to designing, and also looking at landfill closures. And she has a broad bandwidth of experience in not just waste in landfills, but also extending it to water, wastewater, and stormwater asset development and procurement. So please welcome Kate Beard.
All right, I'm not as tall as Kartik. Thank you, Kartik. Hello, everyone. I'm Kate from SMEC, and I'm here to talk about preparing your landfill for capping and closure. Hopefully my voice holds out. It's been dicey all week. All right, we'll start with an acknowledgement of country. I would like to acknowledge the traditional custodians of the land on which we meet today and pay my respects to elders past and present. About me. Am I pointing at? Hey, there we go. So, I'm a civil engineer. Don't let my youthful good looks deceive you. I've been working in this industry for almost 20 years. I'm excited to be in a room full of landfill nerds, to be honest. I'm sure you can all appreciate trying to explain to people what you do. I started working at Tamworth Council as an undergraduate under Peter Resch. I'm not sure if we've got any Tamworth people here today. I've been chasing a few of them down. I remember being told by him, I'm pretty sure my first day, kept saying this word leachate, and for the kids in the room, that was before smartphones, and I was sitting there going, I don't know what a leachate is, and I couldn't run off to the toilet to Google it. What is a leachate? I don't even know. So I know a lot of our jargon and terminology can be a little bit impenetrable. Having done this, we'll hop to it in a minute, but having done landfills for a while now, I'm trying to demystify some of the jargon and some of the processes. I've been working at SMEC in Newcastle for 14 years. If you haven't heard of it, you're in good company. Lots of people haven't. It's the Snowy Mountains Engineering Corporation. It's another engineering consultancy. It was spun out of the back of the Snowy scheme, which is its own fun story. It covers all of the major disciplines: roads, geotech, water power, enviro approvals. I'm sure I've offended some of my colleagues by leaving someone out, but that's the key landfill-related bits. The waste team has been growing rapidly. Our New South Wales waste team has approximately doubled in size in the past 18 months. Supported by the broader SMEC team, the waste team has staff up and down the East Coast, and we have colleagues all across the country and internationally. As was alluded to, I have a broad civil background, and I started in subdivisions, stormwater roads, and I spent a lot of time designing water and sewer until I accidentally sidestepped into the glamorous world of landfills almost 10 years ago. Like most people in the industry, I didn't grow up telling my mum that I wanted to be a landfill engineer when I grew up. But it turns out that landfills are really interesting. I was surprised when I started at the lack of prescriptive rules and, standard drawings, standard things that you do. Something as pedestrian as water and sewer reticulation. They have rule books, over an inch thick each. And I picked up the design guidelines for landfills. I'm like, where are all the rules? Where's the rules? So that can be a blessing and a curse. And so the following is a bit of a summary of practical constraints, things that site operators can do to make my life easier when it comes to design, hopefully saving time and frustration and money for all. I think the slides will be available from the conference later, but if you're after these in particular, there's a PDF on my LinkedIn page under presentations as well. I've been learning how to LinkedIn. Hooray. All right, so this isn't actually a cap, this is one of my projects. This is the first one that I did by myself as the design engineer with the training wheels off, and I'm quite proud of it at Port Macquarie Council. It's a snazzy time lapse of the whole thing being constructed, and that's something else that we would definitely recommend for these construction projects. It's just a proprietary product, we don't sell it, but we have lots of clients that use them. It takes a photo every 10 minutes, and you can tell the contractors that so you can make a pretty time lapse for your presentations, but honestly it's just useful to be able to keep an eye on what's going on every day. And we were able to monitor our construction projects all across the country somewhat remotely. So yeah, you can see Cairncross being constructed there. You'll be coming across, there's a lovely flyover at the end that shows the stormwater separation bunds, which are there to minimise leachate generation. So I'm going to jump ahead. We don't need to watch all of Cairncross being built. Go watch it. It's on my LinkedIn. You can see the stormwater separation bunds. We're very proud of that one. Oh, there they were. Terrific. All right. On to closure. Water flows downhill. Water management is a key principle of landfills. Everyone likes to think landfills are about garbage, or sometimes my geotechnical colleagues tell me they're geotechnical problems. The majority of the significant issues that we see at landfills are water-based. A quick primer, we've got a broad church in the room, as we always do in landfill presentations. We have three water streams. We have leachate, which is dirty garbage juice, water that's touched waste. We have sediment-laden water, which is water that's run off day cover, so it's picked up sediment soils, looks like a chocolate milkshake. And you have clean water, which is storm water, which is run off the grass. When you're planning your site, obviously you've got high sides, you've got low sides. I spent 5 years at university to be appropriately qualified to tell you that water will flow downhill. You need space at the bottom of the hill for your leachate and sediment dams. Obviously you understand the operations of your site. Of the three water streams, sediment is the most relevant to capping. We'll go there in a second, but I left myself a note. I'm not talking about leachate today, but the other question that everyone comes to ask me is my leachate pond big enough? And I will say, it depends. How much leachate do you make? And then you will say, I don't know. So it's tricky. Go get some flow monitoring. That helps everybody. Back to capping. Sediment is the most relevant to capping projects. So if your capping is broad-scale earthworks, then to put down your low permeability layers across the top. The most economic way of doing that is with large machines, rip, tear, bust, off you go. You want to have it all open all at once. It's probably the largest sediment load that your dams will ever see. So we've seen regulators, hello to the regulators in the room, aggressively prosecute against sediment water discharges. I would argue they're perhaps not the most significant of environmental issues that can happen at a landfill, but they are very easy to prove. We've had clients who've been issued 6-figure fines, so it's boring, but boring things are still important. You should understand the capacity of your sediment dams, so both cubic metres and how much area they can support in what rainfall event. We use terminology like a 80% 5-day storm, so that means that 80% of the time you should be able to catch 5 days worth of rain. So it starts to rain, it fills up over 5 days, gives you some time to deal with it, either to flocculate, treat, or just let it settle and discharge. So you can divert clean water out of your sediment catchments. You will have, when you're capping, a conflict between your operational use of your sediment ponds and your capping works. You both want to use the same pond. If you have a breach, whose fault is it? Make sure your contract documents say. And that is water. The only thing that matters is the edges. So I started doing this. My boss said this to me. It took me about 3 goes for this message to sink in. You look like a bright audience. We'll see if we can get you there a bit faster than it took me. So this detail, there we go, hey, is a standard cap, 2016 cap with geosynthetics. That's New South Wales terminology that's sort of similar all across the world, the world and Australia. That detail there is like 90% of the work, right? Put down some dirt, put down some low permeability, more dirt, more grass, off you go. The trick is what happens at the edges. The edges are constrained, so we need to think about your fence. We need to think about where your property boundaries are. We need to squeeze in access tracks around the outside for monitoring and other uses. And we need to think about the drainage infrastructure, the open swales that we were discussing before for our water, which is flowing downhill. The cap also takes some room. So over here you can see the problem is we actually folded that guy down because we ran out of room. But the cap itself takes some room at the edge. So the key message is here that your waste can really only go to there. So if you're placing waste, don't put it all the way to the fence, okay? Give yourself a margin at the edge. Space makes everything easier. If you're tight to the edges, get a proper cadastral survey. Most surveys don't include a full boundary definition. It's a little bit more expensive than a normal one, not anything outrageous, but it's just more than normal. It's not normally needed. The database extracts, I would say, are normally within 1 or 2 metres accurate, but I've seen some rural ones that are up to 7 metres out. So if you're getting jammed at the edges, you're doing work at the edges, work out where your edges are. Clear definition of the edges helps. All right. I pointed to the right spot. Don't set your landfill on fire. So I know we've been discussing this elsewhere on batteries. This is about rural fire. A lot of our landfills are surrounded by beautiful native bushland. these guidelines are from the New South Wales Fire. I'm sure you can steal them for any state you like. They provide some really simple, useful guidelines for what they're looking for. And if I flip to the next page, there we go. We have down here, this is the key message, is every 250 metres you need space to pass or you need or turn. And so you can see here we implemented it at Cairncross. Here's my Port Macquarie landfill. Here, and here. So it's not hard. You could also just do it with like a gravel turning head or something like that. So it was baked into the consents for Cairncross. It was required, but having seen it and how easy it is to do, I would recommend it to everybody. Let's keep our rural fire service volunteers safe. Means on a single lane access that they're able to turn around and escape in a worst case situation. Slopes. All right. This is aimed at helping you to answer the question, how steep is your landfill? Again, a quick primer, we have a broad audience. Engineers, we use 3 ways to talk about slopes: a 1 in something slope, a percent slope, or a degree slope. Here's a handy little table to convert between all of them for you. 1 in X is just rise over run, if you remember your triangles from school. So if you have 1 metre contours on your site, what is the distance from one contour to the next? It's 5 metres. That's a 1 in 5 slope. You can also measure it yourself. I have an iPhone. That's just the standard measure app, and you can just use it to measure degrees off horizontal. So you can go and measure it. This was my family holiday recently, my poor children. That's a road that is 1 in 5. It is steep if you were trying to push your whining children up it. The key message on slopes is, so we need to worry about our edges and we need to worry about our slopes. We're talking here about various examples of slopes that are relevant for landfills. You might all know Victorian landfills officially cap out at 1 in 5, although I know there are plenty which are steeper. There's plenty of 1 in 3s, 1 in 4s in New South Wales where it hasn't been regulated. And I've seen plenty of waste slopes up here in this range. And when I expressed concern, they said, well, it hasn't fallen down yet, which is also a good metric. Just don't ask me to bless it. Okay, so if you're steeper than 1 in 5 on your edges, that's where we need to start being concerned. So if we're putting in the geosynthetics, they're slipperier than a soil material, which we might have used for capping in the past. And the risk is if you're too deep or you're too slippery, is that your whole cover might slide off and end up next door, which is clearly suboptimal, as my brother would say. If you've got something that's steeper than 1 in 5, it's not impossible. There's more engineering that's required. There's procurement risks and issues, and I can talk you through all of those fun things. Just make sure you plan and give yourself some time. Utilities, in-ground and overhead. Where are your utilities? You don't know? You're in good company. Nobody ever does. We've hit more utilities than I care to admit in the investigation works we've done at landfills. If you can spend some time working it out or working out your best guess on what is in the ground anywhere where there might be earthworks or where we might be doing geotechnical investigations, it just saves a whole bunch of headache for everyone. Obviously, you can use a service locator, you can access your own site operator knowledge. Often the operators have been there for a really long time. You can use a surveyor to put it on a map. Councils should have access to a GIS department, so you should be able to. I've always been amazed that councils seem to do water and sewer and stop there. You should be able to get your GIS department to do it. If not, surveyor, and if you want to do it yourself, I'll give a shout out for QGIS, which is open source software. You can find your nearest computer inclined millennial and get them to map it for you. We use that product a lot as well, supporting our remote clients, sending us photos, locating them. So the use of technology is really supporting us. I'm going to reel along. Extent of waste. How much area do I need to cap? Some sites are really well planned and that's known. A lot of our historic sites in New South Wales are a little bit higgledy-piggledy. On day one, I want you to tell me the edges of where do you need this cap to go. we can do extent of waste investigations, but you don't need an engineering degree to dig a hole and to determine if it's waste or not waste. It's certainly something you can do yourself. We would suggest notching the side at 20 to 50 metre spacing, mark a stake, extent of waste, write the test pit number, take a photo, say we've got some records, have the stakes collected by a surveyor, put it on your plan. See, you don't need me. Oh, and be cognisant of your waste exhumation obligations. Some of our clients are concerned about waste exhumation and that you might need a permit. Don't forget that one. Relocation of waste. So this is something that people often don't think about, but so for anything with geosynthetics, which is a lot of the caps these days, it's like wrapping a Christmas present. It needs to be smooth and it needs to be regular. It can't be a hummocky, hilly mess. So we always have to do a bit of cutting and filling. You can see my cut and fill there. Red is cutting, blue is filling, yellow is leave it where it was. So that's the earthworks that had to be done at this site to make it regular enough to be able to line it. People like to imagine that I can take that up into 300 mils underneath the geosynthetics, and it never quite works out that way. So be aware that that's required. Again, waste exhumation obligations. Sometimes we prepare waste exhumation management plans just to step through the OH&S side of those. Or, even better, save yourself all this trouble and just fill to the right profile to start with. So if you've got top of waste contours and fill to those, it saves you a whole lot of problems. So I think we're not doing questions now, so I'll pass it off. But thank you for your time. Thanks for listening to me, and hopefully you've left with a better understanding of the steps we go through to achieve capping and closure.
Thanks, Kate. That was really great. And you touched on leachate, and obviously capping is one of the aspect within landfill to reduce your leachate infiltration. So moving on, it gives you a good segue to the next presentation on leachate management. Our next presenter is Ronan Cullen, who's a founder director of Talis Consultants with over 20 years experience again with international and national projects. He's very much specialized in procurement, contracts, and strategic plans, and has been pivotal in working with the two waste-to-energy facilities in Western Australia. So please welcome Ronan Cullen. Thank you.
Hi guys, yes, lift us up a tiny bit, thank you. Yes, I'm here to talk about leachate. First things first, let's talk about substitutions. Is that working? This is Matthew Hobley, and he was supposed to be giving this presentation. He's one of our waste engineers. He heads up the our East Coast Waste Infrastructure team and based in our Brisbane office with Kartik. And he's not here today, and I'm here. And I can tell you that if I was on Mastermind, leachate would not be my specialist topic. But we've got a presentation prepared and we'll work our way through it. So what we're going to touch on today, guys, what is leachate? I think we all know that. That'll be pretty quick. How do we model it to understand, what we need to manage? We'll look at different treatment options. Of course, leachate to sewer is something that's been used internationally here in Australia. We are looking at the idea that, untreated leachate to sewer, which we'll discuss. And really, like a lot of the other guys were saying, and my fellow presenters, is really just planning for the future to make sure when we are going to be looking after leachate, we're making smart decisions along the way. So what is leachate? We touched on it. Basically water that gets in contact with waste or also where waste has been held. Of course, waste is wet and we try to dry it out, so we're not paying gate fees on water as much as we can. But also too, rainwater, and some people might have some very special sites that have soggy bottoms, as we like to call them. And groundwater is touching the leachate, touching the waste, and therefore generating more. Multiple sources or locations of generation across the site. Obviously, a key one that people also got to be mindful of is on your ponds as well. When rainwater falls on top of it, you're going to be just generating more and more leachate. And of course, it's got various contaminants of concern, and PFAS being the one really on the high on the agenda of late. Water balance, obviously, make sure you get one done, guys. You can only manage what you can measure. And of course, the New South Wales guidelines give some plenty of guidance on how actually to do that. And of course, for lower facilities, smaller facilities, less than 20,000 tonnes, there's default values. Beyond that, you got to be looking at the health model. So hydrological evaluation of landfill performance, more detailed analysis really on what we think is going to be generated. First things first, we don't want it, so let's try and minimise generating it. So obviously, key part of it, as Kate touched on, was the capping side of things. But even going back to the very early days, is planning for your stormwater and leachate management requirements from day dot of your facility. Optimising landfill cells designs. It's great. You go to a client and go, look at this cell I built. It's 10 years of void space. Well, it's 10 years of leachate generation. So be very smart about how you're actually designing your leachates, your cells. Including, particularly in some wet areas that we've worked in cyclonic areas, basically trying to build cells every 2 to 3 years, just so you're minimising the amount of area that's actually open and exposed and going to generate your leachate. And progressive capping. So really, ideally, the landfill's heading in one direction. You're building your new cell, you're capping off the old one, and you're constantly working. So you're trying to minimise the amount of open space. And of course, intermediate cover or intermediate capping or cover, don't underestimate the importance of that in it. But regardless, even the driest part of Australia are still going to have a leachate. And of course, I'm from Ireland, you may have guessed that. Leachate, a very wet part of the world, and a lot of leachate there. So I'll speak about more on that. And of course, we have to deal with it. So we've got to be planning for it from early stages. Infrastructure. So look, it varies across Australia. It varies internationally too. But of course, came to Australia for the sunshine, it's there. Evaporation is definitely an option, but we will talk the difference between evaporation and storage. Ponds, mister systems, various things, heating it just to assist with the evaporation. Other areas where evaporation is not going to work, and even sites that are maybe constrained, you might be thinking about farms for storage. And of course, there is disposal options then through to sewer sewer treatment plants or wastewater treatment plants, and of course some pre-treatment options, and also irrigation and recirculation, which we'll touch on all of them as we kind of go through the presentation. As we said, Australia, large landmass broken into 5 classifications in relation to climate, and obviously your leachate solutions need to be tailored to your particular location in relation to generation and also treatment. Evaporation. So obviously, as I said, a lot of people move to Australia for the sunshine. We should try to use it in relation to get rid of our leachate where we can. Of course, in some areas it's not suitable, but a lot of the places it is, which we'll touch on as we go through. But be very mindful too of the significant changes across the seasons in relation to evaporation. So in Coffs here, summer we're having up to half a metre, but then in winter it's only 200 mils. So we've got to be very mindful of that. If you look at the evaporation side of things in a little bit more detail, I just want to touch about how we design leachate ponds, or as I should say, the team designs leachate ponds. I do not do that. As I said, plan early and do it once, do it right, really. Yes, still working. Obviously, we've got to define our inputs, so using the help model or other tools, we need to determine how much we're going to generate, and then also outputs, how we're going to get rid of it. What is actually the approach there? And particularly being conservative with that approach is very important, because with the leachate side of things, you want to do it once, you want to do it right, so you don't have operational headaches as you go. Obviously, you got to think about the average, the 50 percentile, but also what's going to happen in the wet events, right? Also, what's going to happen on a monthly basis, because it will change, as we said, the evaporation rates and even the downfalls, the rainfall was going to change over the year. Think about that seasonal trends, but also over multiple years as well. The New South Wales guideline says, 1 in 25 storm event for 24 hours. That's the minimum. But of course, in cyclonic areas where we've worked in many locations, particularly in the West, we've designed some systems, 1 in 100 storm events, 72 hours, so longer duration, much bigger events. And of course, we've got to think about the pan factor in relation when it comes to evaporation. And New South Wales 0.7, WA doesn't have any guidance, but of course, BEPN, Vic BEPN has 0.8. So it does vary around the world about how that works, and we'll just chat about that, as I said, shortly. A key one, as we said, guys, is making sure we're planning for multiple years, and particularly with the, New South Wales has had some wet years of late, nearly make me homesick, the weather over here at the moment. But as we see here, we go out and meet a client, oh yeah, I'm all sorted with leachate, yeah, we got storage capacity there, oh, it's over a 2-year time frame. Okay, but what happens over a longer term time frame in relation to will you have capacity? So the graphs we're showing here, the first year is at very large storm events, and then it's just averages. But you can see over 2 years you're okay, but actually over 5 years you're going to get yourself in trouble. You don't have enough capacity on site to actually hold this leachate. So it's very important we are looking at that longer term time frame. Also too is, you know, if the pond's not available or you haven't got enough capacity, what else can you do? So tanks, or sometimes even holding in a landfill, mindful of that, saying that to the regulator, but anyway. So we've obviously got to be mindful of that. So having that longer approach is very important in relation to the modelling works we do for determining infrastructure. We spoke about previously on the evaporation rates across Australia. The graph on the side, obviously, the graph here we can see, I've got a point there. This is just a GIS tool that we've developed, obviously getting some BOM data. And this is probably where we generally start with our clients straight away once they come in. So depending where in Australia we can see in the summer, yeah, we can have plenty of evaporation across the country. But in the winter time, you can see, no, we actually don't. So all the white stuff here, we're actually not getting any evaporation. So really indicates Victoria into, you know, New South Wales in there, it's just not going to work. Also, the main thing we've got to be mindful of is that different areas have different microclimates. So here, actually, in relation to Coffs Harbour, we can see actually in the summer, we don't have any evaporation, but in the winter we do. So be very, very mindful of your settings and plan accordingly. As we spoke about that pan evaporation rate, so because when you do build a pond, and that is the treatment option you're going for, or even if you do have a pond just for storage, the pan factor, which is 0.7, means actually that would be further reduced. So as you can see here, this is the winter again. So you can see we're getting more and more white areas here. So very important that we obviously take that longer term view, and also too in relation to the changing climate we have at the moment. Very important we're conservative in our approach to doing that. Talking about ponds, so I don't think I've been to a landfill, well actually probably one or two very small ones that have no infrastructure for leachate at all, but whether you're using evaporation or just storage, you're going to have a pond. So very important that we actually think when we actually are looking at designing these facilities. So location is key, particularly if you're trying to encourage as much evaporation as possible. So, you know, not in the bottom of a hill, but, you know, sorry, at the top of the hill, not in the bottom of a valley or something like that. So minimizing the amount of actually sunlight that can get in there, and wind too. Be very mindful of whether your your pond is supposed to be for evaporation or storage, because the designs are very, very different. Storage, so many sites we've worked on, we have big storage ponds, should I say, small surface area as deep as we can get them. But then on the side we have large, very shallow evaporation ponds. So when we were pumping the leachate in there, it can heat up nice and quick and we can get rid of it. So very mindful that we're thinking about how we actually are designing our ponds. And realistically, if you are looking for evaporation, it should be ponds. Irrigation or circulation. So irrigation, yes, it's an option that's been used here in Australia. It's the first time I've seen it. It's also the first time I've ever seen a snake in the wild in Australia, my first year in Australia. I was scared by boat, I could tell you, because coming from Ireland, irrigation of leachate is just no. So obviously there's some untreated and also treated irrigated leachate nowadays. But you've got to also be very careful about how you're doing that. So obviously not in the winter and the high rainfall events. And if you are, you've got to have a very stringent monitoring regime to make sure you're not having undue downstream impacts in relation to irrigation. Irrigation is a treatment method because you are going to get rid of it, while recirculation is not. You're just basically moving around your site. So it is an option you can use if required, particularly if you've got a large events and high leachate generation event. But you are just moving around, so be very mindful of it. But also, too, be very careful how you do it, because a lot of people say, oh, yeah, we just irrigate or we just recirculate. Also has to be controlled, because you're wetting the waste mass, also, or saturating it in some instances, or also even your soils or your cover or your cap, you kind of have stability issues, so, which is evident from this picture, which is actually a site in New South Wales. So there was a slip of the cap. So again, definitely options you can use as required, but again, tread carefully. Think about it. Make sure you're doing it in a controlled manner. Disposal of sewer, something that was very common with, obviously, in, when we use from sewer, either generally wastewater treatment plant, but either through sewer or to tankering. Other parts of the world, really, it's tankering to a wastewater treatment plant. So to sewer, a common practice here, but what we are, and there's licenses and permits that have been obtained in the past. And of course, some of it is just currently untreated leachate. But we have seen from our experience, particularly in New South Wales and the Northern Rivers regions, that, and actually in the South Coast, that there has been pushback from the regulators in relation to permitting this. And that has been a big game changer for many of our clients or landfill operators. So it's a significant change, and generally a change that haven't necessarily planned for, unfortunately. And that means that we have to think and reconsider what our options are. Obviously, pushing towards, if we are going to sewer or wastewater treatment plant, is the pre-treatment. And I've been talking to many people here at the conference about pre-treatment options, and there's plenty of people who have far more experience and knowledge of those than I am, but there is a range of them that you can use. And realistically, it depends really on your site location, your concentrations, what's in your leachate, even the volume you have, and also what you're trying to do with it. So there's a variety of options there, which I've listed up there: biological, physical, or even chemical treatment. But most of the sites that we're seeing is, it's an integrated approach. Some technologies will do certain things, other technologies will do other ones. So you need to look, as I said, what your requirements are, understand them, and engage with these technology firms and seeing what's best fit for you guys. But what it is doing, it's having significant cost implications for landfill operators, and as I said, generally unplanned. So, and really increasing the gate fees associated with your landfill. The other one that we touched on, and even some of my fellow presenters touched on, is obviously just these extreme weather events. We're having more and more of them. It's getting wetter and wetter, and we're having big events too, as in big downfalls. So it is coming, and we're seeing more of them more frequently. Actually, even talking to the guys, 1 in 10 events. Sorry, 1 in 10 year events are happening so much more than actually not even 1 in 10 year events anymore. So just really be taking that conservatism in it, but also not just on the design, but in relation to contingency, as in, are the pumps even suitable or large enough to pump out that volume of water from your leachate or from your ponds and so on and so forth? Is a freeboard enough? So really just emphasising the point when you are designing not only your leachate system, but your surface water system, which Kate touched on, is that conservative approach nowadays with our changing climate is really important. Key takeaways, guys. Look, just to summarise what I touched on is get a water balance done. Obviously, it's absolutely critical. You can only manage what you can measure, and be conservative in that approach. Be smart on your site design, particularly when you're setting up. We've been lucky enough to start. We've been involved in projects that were actually starting from day one, site selection studies, design, approvals, all the way through, and it's great. And you can really see how you can, being smart in your design, is minimising your risks and your operational issues and challenges later on. And of course, leachate is the main thing we're trying to avoid in relation to landfill engineering. So being really smart on that. If you got the sun, use it. We've got plenty of clients in Western Australia where there's plenty of sunshine, and really those clients shouldn't have leachate issues because we got so much sun we can get rid of it. So just making sure we are recognising it, but of course that's not going to be suitable for everyone. As I said, more and more scrutiny on that untreated leachate to sewer. So that's where we got to be looking at those pre-treatment options, which is basically, from my view of the world, my experience in Ireland and the UK, that's where that's what has to happen, and that's what's regulated elsewhere in the world, and I think you'll see it more and more coming into Australia. But but that pre-treatment is set unplanned, and that is increasing the cost, your operational and your capital costs associated with your landfills. So make sure we're planning ahead as much as possible. If you currently have untreated leachate going to sewer, I'd say think about it, because you might be able to do that for too long. But also too, it's not just necessarily just thinking about your leachate treatment plan. It's also, does this change mean that we are altering our residual waste strategy? So really, if we have a landfill, do we really need a landfill? Is there other options we can use our residual waste? So obviously been involved in some big waste energy contracts in the West. I do believe they will come here more and more. It is an option for you to get rid of it. Let's do that. Or can you give it to someone else? If you've got a small little landfill, do you really have to operate there yourself, or can you give that to someone else? Do you have to go it alone? So if you have to build a facility, do you have to go it alone, or can you do a regional approach which then spreads your costs, your operational costs across multiple facilities? So really, in relation to leachate, big changes there happening, really needs careful consideration, but don't be afraid to go back to the start and actually consider, is landfilling by myself at this landfill site the right approach in relation to your council? And that's my presentation.
Thank you all. And thanks to all the presenters who kept to 20 minutes. So we have 10 minutes for Q&A. So may I ask all the presenters to come on the dais, please, to take on any questions from the audience. Thank you. So look, there's a cumulative 80 to 100 years of knowledge and experience here. This is the time for you to raise or pose any questions. Go for it. Any questions?
How did you get to that age number?
Not the age, the cumulative knowledge number. Yes, Levent.
Levent Hilling from AGL. From my background in landfill gas management, I just had a question for Jessica around the balance between managing environmental impact of landfills versus the value driver of generating ACCUs and power with the boundary wells and gas migration.
So I think that the primary reason for putting a gas recovery and treatment system in has to be environmental benefit. So there has to be an environmental KPI that's driving the system. So that, and really, if you are doing the right job, and as a landfill gas company, a landfill gas company that is correctly incentivized will be chasing the gas, because every bit of gas is revenue. So anything that's migrating is lost revenue. And so you want to, is that the question? Or?
Hello, yeah. Questions more around the low quality gas in the boundary wells that typically migrate, diluting the gas to the engine or generating ACCUs.
So again, I think that if you are correctly incentivized, it is a balance between environment, because your contract has to incentivize you to meet your KPIs, but you have to have a continuous tuning effort going on. So in a lot of regional sites, because of the distance economies of scale or whatever, you might have, so tuning is when you have your gas specialist come out and adjust each individual well, because every well is flowing at a different rate, at a different quality of gas. So balancing each well, but you can increase the suction on a richer well to counterbalance the a lower suction on, counterbalance a higher suction on a less rich well, to ensure that you, again, are meeting those requirements, to ensure that you're getting the gas that could migrate out. But again, no system is ever perfect. So you might have a site where part of the gas migration issue is leachate driven, or you cannot suck as hard on that well because of a poor capping area. But in general, your contract KPIs and your financial incentives or your commercial proposition should be driving environment and revenue.
Yeah, and I've got another question around the ACCU methodology that you mentioned in your talk. Do you think that, what's the plan if the landfill gas methodology is it scrapped? And if it is, what's the way forward?
So currently previously we had 2 landfill gas methodologies. One of them sunsetted at the end of March, which means methodology lasts for 10 years. If your project is registered already and operating under that methodology, it gets its full 12 years of credits, but no new projects can be registered. And that was the methodology that was very specific to the smaller flaring sites. However, we still have a methodology in existence, which is for sites that have the intent to consider power generation. And since we, as an operator, we have power stations of 1 megawatt on regional sites, that's quite common for us, we believe that every site should demonstrate an intent to consider power generation if it becomes commercially feasible, because things change. Like look at Gympie, right? And maybe in 5 years or so, you could be considering power generation. So there is still the potential to have landfill gas, even small regional sites, registered under the current method. The government has, the department, DECU, has been under caretaker mode, but this new methodology, which should consider regional sites more carefully, we do not know what that looks like yet. We think it will be advantageous, but with rising baselines into the future. It is so much uncertainty. It is very, very challenging. But really, at the end of the day, a regulatory environment should replace the driver of offsets.
I mean, I think, in my personal opinion, I think that landfill gas capture should be part of the financial model of any landfill sort of construction.
Totally agree.
You shouldn't rely on ACCUs to be responsible.
We shouldn't, but there's, I think, the reality of under-resourced regional councils, that if you don't have that regulatory requirement, how do you justify, again, that ratepayer impost? And we have this temporary, I would say, opportunity to get the systems funded, at least for the first 12 years, maybe.
Yeah. I've got a question around the landfill capping presentation as well.
Yeah.
Sure.
Just before we move on to the next question, just would like to open it up to the audience if they have another question, and then we'd come back to you if you don't mind. Sorry.
Oh, well, yeah, no worries.
Yeah. Do we have any further questions? The gentleman at the back there.
Yeah, hi, I'm Ben from the Adelaide Hills Region Waste Management Authority. Another question about landfill gas and essentially ACCUs and dollar figure on ACCUs and potential for that to, rather than having to pump up the price of receiving waste to cover the cost of installing the infrastructure, you know, on a, say, 40,000 tonne of MSW a year landfill, what would be a return on that sort of, on the ACCUs that would then cover the cost so you didn't have to increase the cost to the public?
So if you've got your crystal ball, I'll grab mine and we can compare. But again, everyone's going to have, because it's an uncertain price, the benefit of going sort of, I guess, incentivizing, sharing that ACCU risk with a supplier like LGI is that we operate on a portfolio base. We have big offtakes that secure a forward price for ACCUs. So we can say, look, for this particular share of ACCUs, we can put in the system at minimal or no cost to council. Council may or may not, depending on what we anticipate the flow, the capture to be on the site, may or may not get a royalty or a share of those ACCUs. Generally, with current prices and anticipated prices, there is a share back to most of our council clients, and you can talk to those in the room about it, but at 40,000 tonnes per annum, if it's majority MSW, you probably have a project, and at probably no or minimal cost to council.
Thank you.
Any further questions? Any more questions? We'll go back to Levent. Thanks.
With the capping, I'll put my AGL hat on now. From a solar perspective, have you designed any caps to be able to build a solar farm on top of landfill, as that land really can't be used for a long time and solar might be a good option?
We'd have that question all the time. I haven't taken one personally all the way through. I know they exist. There are a few specific concerns that need to be considered, obviously. Differential settlement, you've got to keep your solar panels pointing at the sun. Conveniently, actually, I sit in the same floor as our solar and power people, so we get to hash this out on the reg. There are more advanced solar panel technologies that can somewhat tolerate the differential settlement. You need to consider the footing implication and how that interfaces with the cap.
Yeah.
It's not impossible. You just need to make sure you haven't put a beautiful cap across the whole thing and then you punch, 1,000 holes in it. I am aware of one site like that, which shall remain nameless to protect the guilty. And landfill gas is obviously your other key constraint if you've got something that's making gas. Thank you, Dr. North. And then you have a whole bunch of electrical conduits and pointing the gas straight at your electrical infrastructure. That is a risk. None of that is impossible. There's just a few additional concerns that need to be considered.
From a risk perspective, it's always just go greenfield and forget landfill, but don't know, maybe there's an opportunity there one day.
I'd like to see it too. And look, there are a few around, but yeah, I think having hashed it out with our power people, it often depends more on your proximity, like the power purchase arrangements that were being discussed here. I'm sure I'm not teaching you anything at AGL. And proximity to decent electrical infrastructure is probably more important.
Yeah, no worries. Thanks.
Thank you. Jump in here.
Nigel Campbell from Lithgow Council. Question for Kate. You mentioned the slopes on the final landform, and then if they're too steep, additional work's required. Do you know how that would compare in terms of cost to the lost landfill space?
Depends. It depends, like everything. Airspace is like gold, right? But it depends obviously on your local council. Have you got a plan? Have you got another beautiful site next door? You're trying to eke out as much as you can. I think as long as everyone goes into it understanding the process, having geosynthetics on a steeper slope is more difficult, and there's, you get some complicated engineering in it. And you can end up with contractual issues. I'm aware of sites that have had, because the difficulty is for people in the room that my textbooks will tell me that, you can't determine what the frictional response is between your geosynthetic and your dirt until you have the specific geosynthetic and the dirt. So you make an assumption at design, it passes all the way through, and then you test it at construction, and you hope that it passes. And if not, there are things that can be incorporated. There are steps that we can take. I think some of my clients are here with 1 in 3 landfills that we're capping at the moment. I think it depends on the site. And have you got 1 in 3 going up really high? It's short. It's obviously a different situation. Does that help?
Yeah. No, thank you.
Yeah.
Just jump on that one and what Kate spoke about earlier on about planning for closure early on in your piece. We had a client, will remain nameless, but they opened up a community recycling centre and the ribbon was cut by the mayor and the big fanfare. The next week we were doing their capping works and we said, well, that needs to move because your landfill is going to come down on top of it. And they're like, no, we're not doing that. So we ended up building a big gabion wall, which cost about $6 million. So very, very costly if you get it wrong. Or red in the face if you want to open a community recycling centre and close it the following week. So it's very important we start early and plan early, yeah.
Yeah, and all the same, the Great Wall of Erskine Park is another one, which was, they were chasing airspace in Sydney, but they put a big MSE wall around so they could go higher. anything's possible. It's just site-specific economics.
Thank you.
Thank you. Just mindful of time. I know we have a few questions, but more than happy for you to interact with the presenters at afternoon tea. So with that, we conclude this session, and thank you all. And please thank all our presenters who have given us very good insight. Afternoon tea is in the foyer and is being sponsored by Cleanaway. So enjoy, interact, and we'll reconvene at 3:30. Thank you.